Should we start? Okay. Now it's too late to leave. So welcome everyone to this very last session of presentations of EclipseCon Europe 2015. I'm really happy to be here talking about EMF Compare and how you can use EMF Compare to create tailor-made, very customized model comparison for your modeling language. My name is Philipp Langer. I work with Eclipse and I'm a committer on EMF Compare. Actually, there are other people that helped a lot with preparing this talk. That's Laurent Deleg from Obeo. He promised to be here, but he's not here. But who is here is Maximilian Kögel. He's also from Eclipse Source. He also supported. Right. So when there are the mean questions, I will forward them to those guys. All right. So just before we start, who knows EMF Compare already? Okay, that's very good. Who has seen code of EMF Compare already? I don't believe you, Mikhail. All right, so that means I can move rather quickly with the introduction. So EMF Compare, as you probably all know, is a framework that allows you to compare and merge EMF-based models. Mostly this is done in the context of version control systems. So when you have something, for instance, like Git, and when you joined the talk yesterday about the integration of EMF Compare and eGit, you probably know what I mean. So when you have a couple of versions of a model, you want to do two-way comparison to, for instance, obtain the differences that you just applied to a version. You want to know what other changes that happened in parallel, actually how they affected the model. And eventually, you often want to create the merged version that consolidates all the changes that have been applied in parallel to a model. So EMF Compare has that covered: two-way differencing, three-way differencing, and merging of concurrently modified model versions. EMF Compare also ships with a lot of viewers, which are more on the tooling side. So it provides viewers to show differences that have been identified to users. It allows to interactively merge specific differences that are there between two model versions. And if there have been conflicts between two parallel changes, it allows users to decide which of those differences that make up the conflict should be rejected and which of those should be accepted to finally lead to a merged version. Besides that, as already mentioned, EMF Compare is integrated with Eclipse team providers. That means you can use it with version control systems. One of the most recent additions is a very good support for using EMF Compare with eGit that allows you to just version your models as you would do with code. And there is currently a lot of work going on to adapt and customize EMF Compare to work very smoothly and on a very close level to how Papyrus modelers would expect differences to be shown, so that you get a very smooth experience when you version UML models that are based on EMF, that are based on Papyrus. All right. So one goal of this talk is, of course, to customize EMF Compare. Of course, the first question is when and why should there even be customization, because EMF Compare is there. You could just use it in your project. The major problem is that when you use a modeling language, you actually are used to representations such as this one. So this is in this example, we use Papyrus. You have a visual representation, you have property views and all this stuff. And when you do change your models, you obviously want to get also the changes that you did to these models at the same representation that how you originally applied this model. So the way you model should be as close as possible to how you compare and merge them. So how does EMF Compare overall work? So this, I will try to make this really quick and then come to demos very soon. So EMF Compare is in general a generic framework. So it, instead of focusing, for instance, as in this example, on actions and pins and object flows between those pins, EMF Compare considers this model just as an object tree in terms of an E-object tree. And investigates the model generically without binding all the algorithms that are employed in EMF Compare to specific types. This is, of course, very well realized using the reflective API of EMF. And thereby, we can support every modeling language that is specified on top of EMF. And the process of how EMF Compare obtains differences consists of three phases. So in the first phase, this is called the matching phase, then there is the diffing phase and the analysis of differences. The goals of these phases are quite easy to understand, so the concepts behind that. So consider this small example. We have here version 1 of a model and version 2 of a model. And in the first phase, in the matching phase, EMF Compare tries to find all the corresponding model elements between those two versions. So we, for instance, in this example, have one class here that's called artist, and in the other version there's also a class called artist. So it's quite obvious for us that these two model elements correspond to each other. Besides that, there is also a third, in the second version there is a second class called actor, but there is no corresponding class in the other version. So what EMF Compare gets out of this matching phase is a so-called match model that has one corresponding pair of model elements and one model element that has no match. So with this information we go to the next phase, the diffing phase, and in this phase the goal is to identify all the actual differences that are between each pair of the corresponding model elements. So basically we iterate through all corresponding model element pairs and do a fine-grained evaluation of the differences. That is easily possible because we just have to step through all the features of the respective type of the model element and then compare the values. So in this case, I don't know if you can read it, but in this class, both classes have the feature is abstract, for instance, and on the left-hand side the value is false, and on the right-hand side the value is true. So in EMF Compare will note down a diff element that exactly describes this difference between those two classes. In the next feature, that's the feature superclass of this type, we see on the left-hand side we have no superclass, and on the right-hand side we have a superclass, so there is a second difference that we can note down and put into the model that describes the evolution. And finally, for all classes or model elements that don't have any corresponding model element in the other version, we obviously can conclude that this model element has either been deleted or added, depending on what you see is the previous and the succeeding version. So now we can put the match model and all the differences that we find in a so-called comparison model, which describes the whole comparison, and can do some more sophisticated analysis on this comparison model. And the goal of this analysis is to find out which of those differences are actually equivalent in their effect. So for instance, both sides set a value to B, so that's actually an equivalent change, but you would still identify this change in the diffing phase, but you need to know that they have the same effect. The second type of analysis that we do is a dependency analysis. That's very important to have this information, to know that one difference can only be merged when another difference has already been merged. So here in this example we have such a dependency. So obviously when you want to apply the change that the actor class is added as a superclass to artist, obviously the class has to be created first. Otherwise you can't add it as a superclass for an existing model element. So EMF Compare will detect that there is a dependency between the diff that adds the actor class and the diff that uses the actor class as a value. This is of course important for when you do interactive merging and conflict resolution. And the third type of a relationship between differences that EMF Compare will try to identify is conflicts. That's only, of course, relevant in a three-way comparison scenario, because when you only have two versions, there can't be any conflicts. Okay, so also this information from the analysis phase is added to the comparison model that describes the whole comparison. And now we have all the theory behind us, and we can directly go on to the customization. So of course, the first question is when and why is customization needed? And basically the answer is what I mentioned already before. EMF Compare is in its core a generic tool. That means it looks at all the models only in terms of their abstract representation and in terms of E-objects. But on the other hand, when users actually use your modeling language, they don't really interact with the abstract model. They always use a modeling editor, and that's why there is kind of a gap between what EMF Compare processes and what users are used to see. The problem with, so why is this a problem? Because a modeling editor is more just a tool to instantiate a model. A modeling editor brings a lot of features with itself. So for instance, you have domain-specific views of the model like diagrams or tables. You might have form-based UIs where you edit the properties in some way. And these often hide complexity of a modeling language. So when you do one click or select one value in a properties view, this might actually lead to several value changes in the model. And of course, when a user applies such a change, he or she only wants to see one change because he or she only applied one change. So why should the user see 5 changes that are just implied by those one action that he or she did in the modeling editor? Another aspect, of course, is that users often have not even seen the meta model of the respective modeling language at all. So just using the information that EMF Compare can get from the meta model. So one example is that the class has a feature is abstract. This might be called completely different in a modeling editor user interface. So the user won't be very happy to see, okay, you changed the is abstract feature from false to true. Maybe this might confuse the user. So obviously there is a gap between what EMF Compare processes and what users are using in their daily basis. And this is what can be called the relative customization distance. So actually we don't call it that way, but I thought it sounded a little bit more sciencey and to have a word for it. So you can think of the customization effort that you have to put on top of EMF Compare for a respective modeling environment. You can think of how many customizations do you have in your modeling editor and how much does the modeling editor put on top of the plain model, and this will actually be the distance that you have to go for using EMF Compare in general. All right. Luckily, EMF Compare is a highly customizable framework. So basically the idea of EMF Compare is not to provide a tool that you can directly use for every modeling environment and directly get the closest and best customized experience for users out of it. The goal is rather that that EMF Compare provides a framework that can be used to implement such a tailor-made model comparison experience and tool. So the idea of this customization step is to take the generic support of EMF that only works on the abstract model and make it domain-specific. Basically, it's exactly bridging this gap. And there are several ways of how you can achieve that. I categorize those ways into 2 categories. So the one is what you can extend and change in EMF Compare core. So that's really the process that applies the matching, diffing, and analysis of the diffs. And the second category is about what you can change in the user interface to make it more close to the domain. So what are the EMF Compare core customizations that you can do? If you remember, we have these 3 phases that I mentioned before. Here is actually a 4th phase that I didn't put on the slide before. That's just merging the differences that you obtained here. And in each of those phases, you can apply different customizations. I don't go into all of them. I don't go into detail about all of them, but just pick some and bring some examples. And in the end, there will be demos, of course. So in the matching phase, remember the goal is to find the corresponding model elements between 2 versions. So of course, you need a way to iterate through your model and get the closest model element to the one that you're currently having in your hand. And obviously, this can be domain-specific. So by default, EMF Compare offers an ID-based match or a name-based match. And if you, for instance, happen to have a modeling language where the identity of a model element is made up by combining, for instance, 2 features, then you obviously need to tell that somehow EMF Compare. And therefore, you can, for instance, extend the matching phase and override the matching strategy that is applied in EMF Compare, and then basically you will get asked for 2 model elements and you need to return whether you want to see them as a corresponding pair or not. In the second phase, for instance, you can change for instance, completely the diff engine, which is not recommended in general, but often you have features in your modeling language that you don't want to know any differences about. For instance, there are just counting the version number, and every time when you save, you increase the number by 1, as it is unfortunately in the target platform editor. So you will always get a change when you change something, but the users don't want to see them. So you can add a feature filter, and EMF Compare will completely ignore changes on that feature. In the next step, in the analysis of differences, here is usually a lot of work to do when you want to have a highly customized version of EMF Compare. And basically, I mentioned before 3 outcomes of this analysis phase, and that's the identification of equivalences, requirements, and conflicts among differences. And basically, you can affect or customize all of these 3 analysis steps. So just to mention one example, conflict detection. For instance, if your modeling language represents a calendar or an agenda, where you have events that start at a certain point in time and end at a certain point in time, and then multiple persons can change this calendar, then you might want to raise a conflict if 2 persons added a calendar event that overlap. Obviously, EMF Compare generically won't be able to find out that there is a time overlap, because that's just 2 values in the model. But you can add a domain-specific conflict detection rule for that, to add a conflict whenever such a change leads to overlapping elements. And finally, you can also affect the way how EMF Compare will eventually merge the differences. This is usually needed when you introduce new difference types, which I will come back to later. Another very, very powerful and useful extension mechanism that EMF Compare Core provides is the so-called post-processors. And the post-processors allow you to intervene after each phase and change the resulting comparison model in some way. So here you will get the match model in your hand before it will be passed into the diffing phase, so you can add, change, remove matches. Or after the diffing phase, you can add, remove, change differences, and so on. And this way you can have a huge impact and can change the comparison quite efficiently and in a quite significant way. All right, now coming to the UI-related customizations that you can apply. So as most of you have seen EMF Compare, here is just a screenshot. I will show that in real life in a second. So in general, the EMF Compare merge view is one of the main user interfaces that are used in EMF Compare, and it shows you on the upper hand side, it shows you all the differences that EMF Compare detected in a comparison. And once you double-click a difference up here, you will get the details of the difference in the lower area. We call the upper area the structure merge viewer and the lower area the content merge viewer, because this is basically the overall structure of the comparison, and this is the content of a specific diff. And in this user interface, there are a number of things you can customize. So obviously, very often you want to customize what is actually shown up here, which kinds of diffs are in a certain view, which elements from the model should be used, should be mentioned here to give a context for a specific difference element, and so on. And therefore, you can specify so-called group providers to provide here the respective input. There's always one default group provider that is showing up in the beginning in the comparison, but users can manually change those group providers to switch to different views, and obviously you can also add additional group providers for users here. Then there is the concept of filters, so you can just, even though there are certain differences in the comparison model, you can just filter them away from the UI, so they won't show up here. And each element here has to adapt to a certain type that indicates which content merge viewer down here will be used. So you can, of course, also affect the type that is used here, and thereby affect which content merge viewer is used down here. So in this example, for each change of a notation, that's the graphical representation of a UML model, for each change that affects a notation, we will use the EMF-based rendering instead of just showing the values, for instance. Okay, so just now I think we are good in time, so after 20 minutes we can finally come to the demos. I hope you didn't fall asleep during the theory. So what I plan to show is a very simple library example. This is a domain-specific modeling language based on Papyrus. And in this library example, I will show a few customizations that make sense. So how to add additional filters, how to add domain-specific grouping, and then I will introduce a new diff type. And finally, to show how you can exchange those content merge viewers, I will just give you one example of how this can be used to make the model comparison UI as useful as possible for your users. Of course, just one disclaimer. I unfortunately don't have the time to go very much into detail on how I realized the actual customizations. I will just try to give you a quick overview what is possible to customize and how much effort it would be. Then you can look up in the documentation later how this is actually done. And I will, of course, also upload the code of these examples. OK, so just to show you the example model. So this is a very, very highly used in practice modeling language, which allows thousands of librarians to manage the books that are in the library and the people who can rent or borrow those books. So basically, we have up here books. And down here, we have people who can borrow them. And whenever they borrow a book, there is this arrow between someone who can borrow a book and the book. This is actually Papyrus, what you see here, with a profile and additional styling. So whenever you, for instance, add a book here, you take the book here and add it here. What actually happens is that a UML class will be created and a UML profile application will be created if there is not one, and a stereotype application, and so on and so on. Each of those books, of course, have also properties. I just have to switch now to the resolution is not very great here, but I hope you can still see it. So each book, for instance, has a title, a publication date, year, and so on. And very importantly, the category. So a book can either be a mystery book, a science fiction book. And depending on what you select down here, the color changes. So now this is a science fiction book, so it's green. And when you change that to a mystery book, it's gray, I think. OK, so when we now compare this model that we have here with another model, let me just, I have a Git repository in the background, so I will just compare with other branches. When I now click on the project, go to compare with other branch, and then I, for instance, go to a branch where we added a dependency relationship or a borrower's relationship between John Smith and Into the Wild. We just open up EMF Compare. And what we see here now is, I just open all the items. We see here that this borrower's relationship has been added. Then there is this connector which has been added, so very nice. We can open that up. So I don't know if you see it very well. So down here, this connector has been added. But strangely, there are also a shape called null. There's a shape called null here, and there is a connector called null here. And the reason for that is because when Papyrus creates this dependency, it actually creates additional shapes and connectors, for instance, to represent this label and so on. So, but of course, the user just did one change, so the user only wants to see one change in the comparison. So what we can do now is just add a custom filter. I already added it here, so I called it invisible shapes and connectors. So once you select that, you will only get those changes that the user actually did. And the user added one dependency in the model, and it added one connector shape in the diagram. So that's what we want to see. How is this implemented? Just open that. Yeah. So this is practically the plugin XML with all the extensions that I did for this example. So there is an extension point called RCP UI filters, and actually it's really easy to implement. So it's just one extension point where you specify the label of this filter, whether it should be active by default. I opted here for false because I wanted to show you the effect without the filtering. A description, and of course the implementation. And in the simplest case, all the implementation has to provide of such a filter is one predicate from Guava, one Guava predicate, which returns true or false whether the diff should be shown. So in this case, I just show a bunch of show a diff or hide a diff when it is stored in a specific feature, but it's just in a doesn't make any sense now to put it here. Just to show you that you can hide that. One important aspect of doing such filters is the difference, especially when you apply them by default. The difference will always be hidden in the user interface. So when manually merging, you have to make sure that when the user, for instance, now clicks here and accepts or rejects the change, then you would have to make sure that this also correctly merges or rejects or accepts all the differences that are related to this one diff that you show here, but that are hidden in the user interface, because otherwise they might be left over and wouldn't be merged. So you would have to make sure that the requirements relationship are correctly computed. All right, so far to the first example. The second example is quite often it's useful to have additional ways of grouping the differences in the upper view of this merge viewer. So when I now compare with another branch, 1 second, category changes. Okay, so in this change, in this commit, I added a few books and changed their category. I added books in a certain category and so on. Just open that up. So you have a bunch of added and changed books in there. Quite often for a domain-specific user, for instance, he or she is only interested in the changes in one category. For instance, one person might be managing all the books in one category. So what would help those people is to allow them to group all the changes according to some domain-specific discriminator, which is what I did here. And here now you see that the roots of this tree are the categories that a book can have. So here mystery or science fiction. And underneath these two root elements, you have all the changes that affected the category a book would be in now. So for instance here, we see that in the mystery category, one book seems to have changed the category. So now it's in the mystery, but before it was in the biography category. There's another change, and here a new book has been added to this with this category value. So this is just a way of making the diffs more easily usable for persons in a specific domain. How this is realized is also actually very simple. I mean, it can get very complicated when you do complicated stuff, but that's not by accident, and it is just complicated, right? So what you would have to do for this categorization grouping, there is an extension point called RCP UI grouping, where you can specify, of course, a label, a description, whether this should be only applied in a two-way or in a three-way differencing scenario. You can add a rank, that means on how high it is ranked in the UI. If the rank is very high, then it's the default group, right? And you have to specify an implementation. And in this implementation, you just have to extend either the interface or an abstract class. And then all you have to implement is basically this one method, which is named build groups. And the input for this method is the complete comparison. And what you have to return is a collection of groups. And a group is just something with a name and that contains differences. That's basically all you have to implement. The rest is just on how complex the grouping would be. So in this implementation, I shouldn't have refactored that so much, so now it's much harder to actually understand. But I just look through all the differences and check whether the category has been changed or whether a book has been added in a certain category or not. That's basically all this code does. But important is you only have to implement one method that returns this collection of difference groups. All right. Then there is one last, or actually two more demos, but this is just quickly show them. So quite often you would like to add additional diff types, because EMF Compare by default only knows reference changes, attribute changes, and additions and deletions of additions, deletions, and moves of model elements. But sometimes it's helpful to have more domain-specific diff types. So for instance, when we go back to the example, let's just go here, and so I am currently borrowing a study, how is it called? A study in Scarlet. And for instance, it could be a domain-specific diff. When a book is deleted that currently has been borrowed, then we can assume that this person stole the book, because now it's not anymore in the library, and before someone had it, so now it's obviously stolen, right? So when I now go back and compare with the original version, whoop, bam, bam, and we open up the model changes, we see here now Philip stole a study in Scarlet. So this is a domain-specific diff. And actually how this is implemented, and I just mentioned it quite shortly, this is implemented based on the on two things. So first of all, you have to specify the new diff, of course in an EMF model. And this can be done by extending an existing diff type. In this case, we extended UML diff because we are in a UML model. Then you can add additional features of such a diff type, and then you make use of the post-processors that are called after each step. And after the comparison phase, for instance, you get called and can decide whether a custom diff has been applied, and then just add it there instead of the normal diffs. But you should still keep the original diffs and just mark them as that this new diff type refines existing diff types, because then you can reuse the merging capabilities of the lower level diff types. So whenever someone clicks, for instance, accept or reject, you still have to apply the differences. Perfect. Okay, so we have the stolen thing now. So one last example. So I didn't show you yet regarding the content merge viewer. So you can also exchange those content merge viewer. Actually, you see already a customization in some sense here, because we use the GMF-based content merge viewers. That are the rendered diagrams with the markers on what has actually changed. But in many cases, you don't use diagrams, you use something very domain-specific, right? So one such a domain-specific view that you could maybe have is that you edit your your EMF models with a form-based UI. So in this case, actually what you have here is just a model element that has an attribute first name, last name, and so on and so on. And this user interface is generated by a framework called EMF Forms. And obviously when someone applies changes in such a user interface, he or she also wants to see those changes in the user interface that the user is used to. So what you can do is just to exchange the respective content merge viewer, and I did that already in this example. So when I compare some model element with another model element and open up the comparison, you will get, instead of, you will get all the differences that you see in the upper hand side, but when you double click, you will see a rendered version of the user interface and a marked version of the control that actually has changed. So it's really easy to make this very domain specific, and it's very important to make the gap between the model comparison user interface and the modeling environment as small as possible. All right, so just, I think, last slide. Future perspectives, yeah. So what was the goal of this talk? Basically, what I think is very important to say is that EMF Compare can never be a one-size-fits-all model comparison tool, and this is also not the goal of EMF Compare. Because the difference viewers and all the specifics of model merging and differencing should always be as close as possible to how the user works. And of course, how the user works differences or is different in any domain or in any use case that you have. So whenever you have a customized modeling editor, you will probably also need a customized model comparison tool. So the goal is rather, instead of creating one-size-fits-all model comparison tools, to build a highly extensible and well-performing basis and make extending EMF Compare as easy as possible, and also to try as much as possible to maximize the reuse between what the modeling editor uses and what the model comparison framework uses. So when they use the same APIs, it's of course much easier to customize that. And one example is, for instance, the EMF edit framework. So EMF Compare just reuses the EMF edit framework as probably most of the editors out there. So it's by default, it's no work at all to get the same icons and the same labels in EMF Compare as you would have in the modeling editor. So that's one goal that we also try to work on and to improve on, is to make it really easy to customize EMF Compare and to find out which APIs would be helpful to be shared among a model editor and EMF, and for instance, EMF Compare. Just on a side note, EMF Compare is not a one-size-fits-all model comparison tool, so that's one statement. The other statement is we are currently working on a model comparison tool that is very customized and already very well fitted for certain use cases. This is also shipped in EMF Compare. And in this work, we customize or put customizations on EMF Compare to make it very suitable for versioning Papyrus models, UML-RT models, SysML models within the whole Papyrus initiative. So if you're interested in that, you can go to collaborativemodeling.org. So there will be all the information and the updates on this undertaking. All right, so with this, there is a lot of more information that you can get to. So of course, this was only an overview of what you can do with EMF Compare. It's a very cool project. It makes really a lot of fun to work with it. At least I love it a lot. There is quite a good Compare developer guide that you can use to look up how you can customize things. There is a very active and EMF Compare forum where you will get answers to very specific questions. And of course, you can always contact us also directly if you have questions or issues getting started. And again, follow us on collaborativemodeling.org. So I think we have a couple of minutes left for questions. I'm happy to answer them. Thanks.